Hey, this is Mr. Ward, and I'm going to do a couple of videos on graphing linear inequalities. Now, graphing linear inequalities is actually pretty simple. You start off with pretending you're graphing a line, and then you'll have to figure out one really important thing, which side of the line gets shaded. So I'm going to start off with this one. This is in a a slope-intercept form. Y is greater than 3x minus 2. And we're going to start off by just graphing a line. This is saying y is everything that is greater than the line 3x minus 2. So what that means is we need 3x minus 2, y equals 3x minus 2, as a boundary to define the wall between what is greater than and what is not greater than. Okay, so let's start off by figuring out one point that we definitely can plot. Since this is slope-intercept form, y equals mx plus b, the last part is the y-intercept, so we can plot 0, comma, negative 2. So let's move one of these points over here into position. Okay, it's reasonably close, it's not perfect. Let me adjust it slightly. Okay, now we need to find another point. Now let's turn that slope of 3 into 3 over 1, because that's the same dang thing. And then we have a rise of 3, a vertical change of 3, and a horizontal change of 1. So if I do 0, comma, negative 2, I can add the vertical change of 3 there to the y part, and add the horizontal change of 1 to the x component. And that becomes 1, and 3 plus negative 2 is also 1. Okay, and we could do it this way as well. I'll bring this down over here and plot this on top. So I'm going to go up 3, so 1, 2, 3, and then over 1. And in fact, absolutely, it goes to 1, 1. Okay, let's bring it down just a hair. So now I have 2 points that I can draw this line through. So I need to draw this line through it. So let's grab the line, bring it down. Okay, I'll bring it down a little bit here. I think I need to shorten it so I have room to work. And then rotate it a little bit so it's lined up with those points better. Okay, didn't work. Let me try that again. And then I'm just going to move that over a hair and line it up with those points. We're going to move it manually a little bit. There, we're almost there. Now, mind you that inequality didn't say y equals 3x minus 2. It said y is greater than 3x minus 2. Well, one thing that means is that y is not equal to 3x minus 2. So we need to actually change this line to a dashed line. And the reason we're making it a dashed line is that tells us that the points that are on this line are not part of the inequality. What we now need to do is figure out what points actually are part of the inequality. Now, you might intuitively assume that points that are above this line are part of the inequality. In this case, you will almost certainly be correct, but let's be sure. And a way we can be sure is we can pick some point that is definitely not on this line and plug the x and y values into this inequality and see if it keeps the inequality true. If it keeps the inequality true, then that point and every other point that's on the same side of the boundary line we've just mapped will be part of the inequality. Okay, so when I look at all the infinite points you have to choose from, there's one that stands out as the easiest one to work with right there, 0, 0. So I'm going to take the point 0, 0, and I'm going to replace x and y with it. So that becomes 0 is greater than 3 times 0 minus 2. And then we see if that's true. 3 times 0 is just nothing, so we're left with 0 is greater than 2, or than negative 2. 0 is greater than negative 2, and that is absolutely true. That is a true statement. So we now know that 0, 0 is a true part of this inequality, which means everything else on this side is also a true part of the inequality. And now we need to figure out some way to communicate that this side of this is included. Now, there are various ways. If we were in Desmos, you'd just have one side shaded. But here, what I'm going to do is I'm just going to put arrows going like that. So everything in that direction is going to be shaded. Everything in that direction, that last thing was not intended. Okay, everything on this side of the line is part of the inequality. And that's really all you need to do. Grab an arrow. You could find other ways to do it too. You could get a scribble and just go everything on this side. Okay. Some people may find that less aesthetically pleasing. But there you have it. Either way, draw a bunch of arrows on one side, somehow indicate, or you could just say, get a text box and say, you could just type in over here or this side. You can do that. Okay, so now we know that this side is the side that is shaded. This side is no man's land. Nothing gets included in the inequality. And since it's a dashed line, the dashed line does not get included as well. All right, so we're going to change one thing about this inequality, though. We're going to change it to or equal to. Now, when I change it to or equal to, now that means this line is included. So we're going to make one more change. Instead of dashed, it becomes solid. So if it's or equal to, it's a solid line, and then everything over here. Let's take a look at another one here. Let me undo some stuff. Okay, now I'm going to take a look at this next one. Rid of some stuff that's distracting. Let's look at this one. Y is less than negative 2/5 x plus 1. All right, same thing. We're going to need to plot a point, and there's definitely a point, and then use the slope to map it. We're going to we're going to graph this as a line. It's going to be dashed because it's not or equal to. So let's graph it. So it's going to be 0, 1 because the y-intercept is 1. And then let's plot that point. Go right back up here to 0, 1. And there you have the y-intercept, and now we can use the slope to work out another point. Now the slope is negative 2 over 5 or 2 over negative 5. So we could get 2 points if we want to, but I'm just going to start with 1. So I've got my original point, and I'm going to treat it as negative 2 over 5. So I will subtract 2 from the y because that's the change, the vertical change. And I will add 5 to the x. Now I'll simplify that. 5, negative 1. Okay, and I could, of course, grab this point, put it on top of my y-intercept, and I can go down 2, and then that's a vertical change of negative 2 and a horizontal change of positive 5. And I end up at 5, negative 1, which is just what I predicted here. Now I just need to grab my line. Okay, grab that line and okay, and move it up a little bit to line it up. And now, should it be dashed or should it be solid? Well, why is it not coming out as solid? Let's see what happened here. That line ought to be. There we go. So should it be solid? No, it shouldn't be because it's not or equal to. Since it's not or equal to, it needs to be a dashed line. Now the only thing left to do is figure out which side, and which side of this boundary line here is going to be shaded. So we look around, find some point, one of the infinite number of points. Since this doesn't go through 0, 0, I would choose 0, 0 as the test point. This is a test point. So I'm going to say 0, replace y with 0, is less than negative 2/5 times 0 plus 1. And is that true? Well, 2/5 times negative 2/5 times 0 is nothing, so we don't care about that. So we have an inequality that says 0 is less than 1. And therefore, it's true. So we would plot here, and everything on that side, everything on this side of this boundary line is going to be shaded. So whatever way you indicate the side is going to be in, you can use that. You can use arrows. You can just get a text box and type it out, but communicate somehow that this is the side that's going to be included. That side is excluded. Okay. Now let's do one more test though. Let's change this inequality to y is greater than. And now we're going to test 0, 0 again, and you'll see what happens. Now it's going to be 0 is greater than negative 2/5 times 0 plus 1. In both cases, it worked. Now, negative 2/5 times 0 is just nothing. And now we're saying 0 is greater than 1. So now, with this new inequality, y is greater than the line negative 2/5 x plus 1. Now, 0, 0 is not part of the solution. So we'll just scribble. Oops, that was not what I wanted to do. Try that again. So still doing that again. Okay, for some reason it doesn't actually want me to scribble. Okay, now it wants me to scribble. So we can scribble this side, okay, of the line boundary, and this side is included, this side is not. The line is not included unless I make it or equal to, in which case the line does get included. If it's or equal to, that boundary is part of the inequality. So the line, all the points on this line going forever in either direction, and everything on the upper side of it. All right, I'm going to stop. That was a video on how to do it when it's slope intercept form.